Hello students. In this session, we are going to learn how to write a program in an assembly language and how to execute the same program on the 8085 microprocessor kit. So first we'll see how to write a program. The program is to find out the smallest number. Means a block of data is given and we have to find out the smallest number from that block. This is the problem statement. See, a block of data is stored in a memory location starting from the C500H. They have given the starting address of the memory location, that is a C500H. Length of the block is stored in a register B. And write an assembly language program to find the smallest number from the block of data and store it at the end of the block. So suppose if you take the block size is a 5, so we have to store that 5 into the register B. So length of the block is 5, so we are going to save this 5 into register B. And they have also given the starting address of the block. So if the starting address of the block is a C500H, so we have to consider 5 locations, that is C500H, C501H, C502H, C503H, and C504H. So from these 5 locations, we have to find out the smallest number, and as it is mentioned in the problem statement, we have to store the smallest number at the end of the block, that is nothing but a memory location C505H. Now how we can find out the smallest number from this 5 location? The logic is very simple. We'll just compare the first number with the second number. Whatever number is smallest one, okay, whichever is the smallest one, we are going to place that in one register. Now for the comparison, we have the instruction CMP. CMP instruction is there in the 8085 programming set, and using that instruction we can do the comparison. But in the CMP instruction, the by default operand is your accumulator, that is nothing but a register A. It means we have to keep one operand or the first operand into the accumulator if you want to use the CMP instruction in our program. So what we are going to do in this program, we'll keep our first number, that is a C500H locations data into the accumulator. Means our first number will place it in the accumulator. Then we'll place the second number into the memory pointer M, and then we'll compare the A and M. If A is greater than the M, means M is your smallest number, then we'll copy the M data into the accumulator. And if A is if A is less than M, it means that your smallest number is already in the accumulator, so no need to change the data of the accumulator. Okay, this is the logic we are going to use to find out the smallest number from the given block. Now, our first task is to copy C500H data to the accumulator. Now, how we can copy that data, C500H data into the accumulator? First, we'll copy that C500H data into the memory pointer M, and then from the memory pointer, we'll copy it to the accumulator. Okay, and then we'll increase the HL value. So your second number will be in a M, and then we can do the comparison. So basically, 5 blocks are there, but comparison, we are going to do 4 comparisons are there. 4 number of comparisons we have to do to find out the smallest number. So I have initialized a register B with the 05. My register B will act as a counter in this program. Now initialize register pair HL with the C500H. We know that if you put any address into the HL register pair, then the data present at that location goes into the M. So if you place the C500H into HL, so first value, your first number goes into the M, and then we can copy that data to the accumulator. So we'll copy the M value to the register A. Now our first task is done. We have copied the first number into the accumulator. Now we have to bring the second number into the M so that we can compare the A and M. Now to bring the second number into M, we have to put the second number address, that is the C501H into HL register pair. But HL is already having the C500H, so I'm just going to increase the HL value by 1. So if I increase the HL value by 1, so HL will be C501H. So your second number is in a M. Now your first number is in an accumulator and second number is in a memory pointer M. So now we can compare these two values. So to compare reason, we'll use that compare instruction. We'll compare M with A. Now, if your A is greater than M, if your A is greater than M, means if the small number is present in a M, we are going to copy the M to the register A. And how we can check which one is the greatest or which one is the smallest number? See, for that we'll use the flag register value. In the flag register, we'll check the carry flag. If the carry flag value is 0, if the carry flag value is 0, it means that A is greater than M. So if the carry flag is 0, then we have to copy the M value to the register A. Then we'll decrease the B value because we did the first comparison. So we have to decrease the B value. So B will be 3. Now we'll check whether B is 0 or not. If it is 0, then we'll stop our comparison. We'll stop our program. And if B is not 0, then we'll go to the step 4. Now the B value is 3. So obviously we have to go to the step 4. Means again increase the HL value. So HL will be C502H, means your third number is in a M. Then again we'll do the comparison with the A. Now accumulator is having the smaller number from the first and second one. Okay, then we'll compare that smaller number with the third value. Again the M is smaller than the A, then we'll copy the M to the A. We'll decrease the B. B will be 0, 2. Then we'll check what is the B value. If B is not 0, then we'll go to the step 4. Then again we'll increase the HL value. So HL will be C503H, means your fourth number is in a M. We'll do the comparison of the small number and the M. M is again smaller. If it is smaller than the A, then again we'll move that M to the register A. Otherwise, no need to move that. Then decrease the value, register by value B. So B will be 1. Again the B is not 0. Then go to the step 4. Increase the HL value. So now your HL is C504H. Means last number is in a M. So we do the last comparison. If A is again greater than M, then we'll copy the M value into the A. And now we'll decrease the B. So now your B is 0. If your B is 0, means we have compared all the numbers from the block and we have to stop the process. And at the end of this block, your small number is present in a A, which we want in a C505H location. So to copy that A value into the C505H location will increase the register value HL by 1. So now HL is C505H. Then we'll copy the A to the M, means your smallest number will be in the C505H. So this is the algorithm to find out smallest number from the given block of data. Now we'll write the assembly language instructions for each and every statement. The first statement is initialize register B with 04H. So to put this value 04H into the register B, we'll use the instruction MVI B, 04H. Next is initialize register pair HL with the C500H. So to put this value into the HL pair, we'll use the LXI instruction LXI H, C500H. Third is a copy first value to the register A. Since we have copied the C500H into HL pair, so the first value is in M. So to copy the M value into the register A, we'll write MVI A, M. Next is I want the second number in my M. So we have written the instruction increment register pair HL. To increase the register pair HL value, we'll use the instruction INX H. And we have given the label to this. because I want to repeat this process. I want to repeat from this step. Okay, this is the reason I have given the label to this INX H, that is up. Label, it is just a name given to that instruction. Now next is a compare M with the register A. So to compare, we have used this instruction CMP-M. CMP-M compare the instruction A and M. According to that, your flag register will be affected. Then we'll check the register flag register value. If the C is reset, means if C value is 0, then we are going to copy the value. And if it is not there, if the C flag is set, means if C flag is 1, then we are going to jump to the next location. So here I have written the instruction. See, JNC next is there. JNC next means what? If the carry flag is 1, then we are going to jump to the next location. Okay, next label. And if JNC is not there, means if carry is not there, JNC is there, then we are going to move this M value into A. Next, we decrease the register B value. After decreasing the register B value, we'll check whether B is 0 or not. If it is not 0, then we are going to move to the next step 4. So if J and Z up, I have written J and Z up means what? If Z flag is not set, then we are going to jump to the up level. Then next is the increment register pair HL. So again, to increase the HL pair, INX H is used. Then after that, we are going to copy the M value to the C500H. For that, the instruction is move M comma A, and to stop the execution, we write the RST1. Okay. Now this is how we have written the program. The first is your label. Whenever you write the program in an exam, you have to follow this format. You have to write the program in a table format. The table is of the 3 columns. First is your label, second is your mnemonic, and the third one is your comment. Now, if I want to execute this program, then for the execution, we are going to add 2 more columns in that. That is a memory location and operation code. Memory location means what? Memory location and operation code. Now, operation code means what? Suppose if I want to enter this instruction MVI B, 04H. So that microprocessor kit is having the limited number of keys. So I cannot enter this MVI B, 04H. So what I'm going to do, we'll write the hexadecimal code of the MVI B. Means instead of inserting the MVI B, we'll insert the hexadecimal code or operation code assigned for this MVI B. Next is the memory location. We are going to decide the memory location where I want to save this program. Okay, because if I want to save this program in the microprocessor, then first decide the location where you are going to save it. Okay, now in this example, I have selected the memory location C000H. Means here I'm going to save my program. So as we all know, the MVI B, 04, it is a 2-byte instruction. And since it is a 2-byte instruction, we require 2 memory locations. So first memory location I have taken is a C000H, and second continuous memory location I am taking, that is a C00001. So basically C00H and C001H will have your first instruction, that is MVI B, 04H. Next is the Alexa H, C500H. This is a 3-byte instruction, so we require the 3 memory locations. So next memory location C002H will utilize for the Alexa H, then C003 and C004 is also we are going to use for that address storage. Next is the MVI A, MOV A, M. It is a 1-byte instruction, so we require 1 memory location. Next is the INX H. It is again 1-byte instruction, so 1 location is sufficient, that is the C006H. CMP-M, it is again a 1 byte instruction. So we have taken only one location, that is C00H. Next is a JNC next. JNC next, it is a 3 byte instruction. So we require 3 memory locations, that is C008, C009 and C00AH. Again, next is the move A, M. It is again 1 byte instruction. So we have taken the memory location C00BH. Then DCRB, it is again a 1 byte instruction. So the memory location for this is C00CH. Then JNZ up, again JNZ up, it is a 3 byte instruction. So we require the 3 memory location, that is C00BH, C00EH and C00FH. Next instruction is the INXH. It is a next instruction is INXH. The size of this instruction is again 1 byte. So we require only one memory location, that is C001H. Then next is a move M, A. It is again a 1 byte instruction. So we require only one memory location, that is C011H. And the last one is the RST1. For that, we have available location is the C012H. Now these are the memory locations we have taken for the storage. Now we are going to write the operation code for this each and every instruction. Okay. Now for the operation code, this sheet is available. We are going to refer this sheet for finding the operation code. Now see here, my first instruction is the MVIB. So we have to find out the code for the MVIB. Now for the MVIB, the code is a 06. So in the operation code, I'm writing the 06 for the MVIB. But 06 is for the MVIB. From this instruction, 04 is left. So 04 we are going to write in the next memory location. Similarly for Alexa H, the code is the 21H. Now 21 is for the Alexa H. Now the C500H is there. We have to insert the C500H also, but first we will insert the lower bytes, that is 00, and then we'll insert the C5. So 00 and C5 next location will be. Operation code for the move A, M, that is 7E. Operation code for the INXH is the 23. Then operation code for the CMP-M is the BE. Then operation code for the JNC. JNC is DA. We have to write the code for the next, but next is not a mnemonic, it is a label. So how we are going to insert a label in the microprocessor kit? See, this is my next label. We'll find out the location of the next label in the program. Okay, now see, this is my next label. Now find out the address of this next label. The address of the next label is C00C. So in place of this next, we'll write the C00C. So first we'll write the lower byte, that is 0C, and then C0. Next operation code for the move A, M is 7E. Operation code for the DCRT, that is 05. For JNZC2, again the JNZ up is there. So in place of up, we consider the address of the up, that is the C006. So first we'll write 06 and then C0. Next is the INXH. Operation code for the INXH is 23. Move M, A is 77 and RST1 is a CF. So once this operation code table is ready, after that we can start the execution. Okay, but to execute a program in a microprocessor kit, we have to follow the 4 steps. First is insert program into the kit. Second, now to insert program in the kit, we'll use the reset set address of a program, means starting address of the program, the address where we have saved our first instruction, and then increment. Second step is the input data, where we are going to, in the second step, we are going to insert a data in the microprocessor kit which is required for our program. For that, we are going to follow the steps, that is reset, set, address of a data, the address where we want to save the data, and then increment. Third is the execute program. To execute a program, we'll use reset, go, address of a program, and then execute button. After pressing the execute button, you'll get a friend message on the display if your program is correct or if your program is executed successfully. Now in the microprocessor kit, output will not be displayed directly on the screen. We have to check the locations of the output. So to check the output, we are going to follow again two steps because your output is present is in the either register or either in a memory either register or in a memory location. So to check the register value, we'll press the register button and then press A. And to check the memory location value means if you want to check the output data in the memory location, then reset set address of the data. Here address of data means address of output data and then press the increment button. So in this way, we can execute a program on a microprocessor kit. Now we'll see the demonstration of how we can input a data, how we can input a program, and how we can execute a program on the microprocessor kit.
Okay students, now we'll see how to execute a program on this microprocessor kit. See, first step is to input a program in the kit. This is your microprocessor kit. This is the display of the microprocessor and these are the keys available for the data entry. Now on the display, if it is showing the friend message, it means that your microprocessor kit is working properly. Now we can input a program in that. To input a program in this kit, we'll follow the step reset, set, address of a program, that is your C000H, and then we'll press the increment button. Reset, set, address of a program, that is C000, and then press increment. Once you press the increment button, you will be directed to this memory location C000. Now here I am going to enter the operation code, that is a 06. So here I will enter 06. Now see here I have just typed the 06. Until and unless you press this increment button, it will not be saved in this memory location. So once you enter whenever you enter this operation code, you are going to press this increment button without fail. So if I press this increment button, this 06 will be saved in this memory location C000H and you will be shifted to the next memory location. There I am going to enter the code 04. Next is a 02 location 21, 0300, C004 C5, C005 7E, 06 23, 07 BE, 8 BA, 9 0C, C00A C0, C00B7E, C00C05, C00D C2, C00E 06, C00F C0. Next location is a C010. C010, I am going to enter here 23, C011 77, and the last location is the C012. In the C012, I am going to enter the CF. CF is the last code. After entering this last code, don't forget to press this increment. Otherwise, this CF will not save in this memory location and your program will never end. Here we have completed our first step. Now the second step is to input a program. To input a program, we will use reset, set, address of the program. Now here the address of the program is a C500H. So I'll press reset, set, C500H and then press increment button. Here I am going to enter any 5 numbers. Any 5 numbers you can enter here. I am taking 02, then next 05, 09, 076 and the 07. And this location C505H, it is a 00. We have completed our second step over here. Now the next step is to execute a program. To execute a program, we'll press reset, go, address of a program means this C00H and then we'll press the execute button. Reset, go, C000 and then we'll press this execute button. When you press this execute button on the screen, if the message come as a friend, it means that you have executed your program successfully. Now we are going for the step number 4. There you are going to check the output. Your output is present at the 2 locations. First is your register and second is your memory location. So first we'll check the register value. Then to check the register value, we'll press the register button immediately after coming this friend message. So here we'll press the register A. Whatever data we have entered, in that the smallest number was 02, it is showing the 02. Now the next is the register B, it is 00. According to this program logic, at the end of this program, B value must be 0 because we have initialized B to the 04, and after each iteration we are decreasing the B value, and when it becomes 0 we are stopping our loop. So B value is 00, C value is 00, D is 0, E 00, F is a 55. F is a 55, that is my flag register value. This value you have to note it down. Next is the H. H is a C5. See, in the HL we have saved the C500H, and then we are continuously increasing the HL value. So at the end of this program, your HL will be C505H. So H is a C5 and L is a 05. Now the next step is, that is a step number 4B, where we have to check the memory locations. So we have done this program to calculate the smallest number, and at the end of this program we have saved the output at the memory location C505H. So we'll go to the reset, set that memory location C505H,